Day 46, page 975, number 58. So we're talking about a grading here with 1,000 lines per centimeter. This is, once again, indicating that we're looking at the interference maximums. And it's talking about how many lines per centimeter. Down at the bottom here, I've calculated if there's 1,000 lines per centimeter, that means it's 1 centimeter for 1,000 lines, or in other words, 1 times 10 to the negative third centimeters per line, but we want meters, so we're going to be looking at this. This will be our D. So that's what D equals. D equals 1 times 10 to the negative fifth meters. And we're looking for the angle to the first maximum. I can take the one above or below the central. So bottom line, if I take the one below right here, or I can take the one above, because in this case, they've got theta 1 kind of indicated on the diagram. Let me fix these as well, because in their diagram, L is where the X is, and the Y's are what we call X. That's X sub 1. So we're looking for X sub 1, and here's theta sub 1 right over here. I mean, right over it, theta sub 1. Whoops, theta sub 1. That's that first angle right there to that maximum. So we have everything except theta. We'll plug in. So essentially we'll have sine, this first equation, we don't need the second equation. Sine of theta is going to equal to, we have m, which is 1, times the wavelength of the light. We're using 650 nanometers. Reminder again to put in times 10 to the negative ninth, divided by d, which is 1 times 10 to the negative fifth meters. So everything will be in meters once you factor in the nano in the numerator there. And do inverse sine to get your angle to that first interference maximum. We call it the first order of the spectrum for that particular color of, it's red light. It really wouldn't matter what color it is, but in this case they told us it's red. Although other colors like blue, well, all the other colors wouldn't be as far out. They would be closer to the central maximum. The diagram or the interference fringes would be more compact and squeezed together than the red. The red's the most squeezed out because red is the biggest wavelength. It spreads out the most when it goes through these small slits.